Welcome to Waterloop. Here for this conversation with Martin Bureau. He is Vice President of Innovation with ALTRA Solutions. This PFAS challenge that is so big for the water sector right now. Could you talk a little bit about why this is a tough challenge?
The challenge is complex because these products that are man-made, uh, developed in the 50s more or less, are now everywhere on Earth. They have dispersed into our environment massively, and on top of that, they're very difficult to destroy since they're very stable. They were made that way. It's difficult to destroy them. So first, you need to capture them, and then concentrate them, and then eventually destroy them, and that takes a lot of energy to do that. So the challenge is really related to the fact that they're dispersed from the North Pole to the South Pole. We've got some in our blood. Our children do as well. So it's really an important challenge. It's dispersed throughout the industrial chain. Most of the manufactured products have some of them. They end up in our landfills. They end up in the water that leach from the landfills, and so on. The gigantic global loop is very complex.
Hmm. Ultra Solutions, could you talk about your business and your company?
Yeah, Ultra Solutions is part of a larger group that's called Sanexen. We were founded close to 40 years ago, and we started working on complex contamination in water from the beginning. PCBs was our first focus, and for a good 10 to 15 years, that was most of what Sanexen, that young company, was doing at the time. And by doing so, we developed a very specialized approach to niche environmental challenges and overcoming them with the best and most cost-effective solution that there can be. And then we extended our expertise to all sorts of contaminants in soil, and then other type of contaminants in water, dioxin and furans, chlorinated solvents. And over the course of the years, we were called upon to solve or clean up sites where there were spills. One of which in 2001 on a military base in Quebec, Quebec province of Canada, was a spill of AFFF, aqueous film forming foam, which is actually made of high concentration PFAS in water and other chemicals. So we did our first project of PFAS more than 20 years ago, and we used, conceptually speaking, exactly the same approach that we do now.
Hmm.
But of course, we've improved our techniques quite a bit. But exploiting the surfactant nature of those products, and then filtering them, and then destroying them at the end of the process. That's exactly what we do now. So we did that in 2001, and then there was a disaster in a small town just across the Vermont border, the main border, sorry, in Canada, called Mégantic, Lac Mégantic. A train derailed over there, and more than 60 rail cars exploded. They contained crude oil, sorry, and close to 20,000 gallons of AFFF were used to put out that fire. And Sanexen was there to deal with that AFFF, to prevent it from going to the environment. So we treated millions of gallons of water at that time with heavy contamination, plus hydrocarbons and all the degradation products of that fire, and the AFFF, the PFAS, which came from military base or petrochemical plant around, which were called upon for emergency response. And let's say we did our homeworks that summer and that fall, where we learned so much on how to improve our techniques. So that's in 2013. So 10 years ago, we started very seriously working on this. And now I guess our claim to fame is that for heavily contaminated PFAS stream, we're the leader
Incredible. Like you said, you've been at this PFAS for over 2 decades,
Yeah.
and you have that history working on some of the other famous contaminants, right? Like the PCBs, and now kind of PFAS is the big one that's on the front burner, if you will. So, could you talk a little bit more about the services that you offer? Like, when it comes to PFAS, you're cleaning up contaminated sites. That's one of the specialties.
Well, it depends on the territory. Right now, the way we're positioning ourselves in Canada will be a one-stop shop. We'll do everything
Okay.
from the engineering and design to the remediation and the water treatment and destruction, and we'll do that completely. In the States, growing our presence. Right now, we're focusing on landfill leachate treatment and industrial effluent treatment specifically. We need to start somewhere. And our target is, let's say, medium flow rate. So not the millions and millions of gallon per day, but the hundreds of thousand gallon per day, but at very high concentration. So we will avoid the typical municipal well water treatment that has, relatively speaking, very low concentration in PFAS. You'd consider 100 part per trillion, 100 nanograms per liter
Hmm.
as fairly low, but the
Hmm.
criteria that they need to meet are closer to 1 nanogram per liter. Industrial leachates or landfill leachates, well, industrial effluents, I should say, and landfill
Hmm.
leachates would be 10,000, 100,000, a million. That's typically what we do. And our approach is quite straightforward. What really we aim at doing is avoid any filtration or destruction technology until it's just absolutely necessary, and instead rely on concentration methods. So we capture them by physical or physical chemical means, meaning no filtration, no media, no absorption. We want to concentrate the PFAS as much as we can into that liquid stream or remove it from the liquid stream. 99.9% would be a target. And once we've done that, we're actually reduce the cost of downstream destruction or absorption on carbon or resins or whatnot by a factor of 100 to 1,000, really. So you concentrate as much as you can, and then you go to those, let's say, sensitive technologies that work well, but will be fouled easily, will be extremely expensive. Destroying PFAS, you're talking, depending on the approach, 50 cents a gallon, 25 cents a gallon, let's say at best, to $2 a gallon. Imagine you have a landfill leachate that has 200,000 gallons a day. So that's 500,000 per day for that leachate to treat. It's totally unconceivable to do that. So we come to them, we tell them we're going to be removing most of it and reduce that cost by a factor of 100, let's say, and then that concentrate stream will be dealt with depending on the case. There's many techniques. The preferred one would be destruction, of course, and we will come with complete solutions for that. Partnering with there's several startups right now that work on destruction technologies, and we're talking to all of them, and we're partnering with them and looking forward to have joint ventures on those specifically. But other approach will rely on evaporation in some desert landfill where it's going to naturally concentrate due to the water evaporation because PFAS are a very low tendency to evaporate. So that's going to be safe. There'll be a deep well injection for some, and that will be probably considered as a viable solution for a while, if not forever. And then you could cast them into stone, for example, into concrete monoliths. So you use the seriously contaminated and concentrated water in PFAS as your liquid to cast concrete, for example. And there are other approaches like that. We call them stabilization.
That is fascinating. I know more about kind of the municipal water side, so it's fascinating to learn about these industrial discharges, the contaminated sites, the leachate, that incredibly high level of PFAS that has to
Yeah.
be dealt with. Uh,
And about that,
yeah.
sorry to cut you off, but the municipal need approaches like ours as well. Of course, they will
Mm,
need to deal with the PFAS downstream, no doubt about that. But treating millions or tens of millions of gallons per day is very expensive. Now, I know for a fact in many of those water treatments and publicly owned water treatment sites, the sources of PFAS are very few
mm,
and they're known. It's Google them,
mm.
see who's there, what kind of industry. You might have a chrome plating business somewhere. You might have a landfill. The hotspots, let's call them this way, are very easily, they're few and they're very easily identifiable. So treating there is probably 100 times to 1,000 times cheaper than treating at the plant.
Absolutely.
So this is an approach that Michigan undertook recently, and the results are astonishing. They are able to avoid PFAS in their biosolids, which is what in the product in which the PFAS concentrate at the water treatment plant, by having treatment at the sources and either avoiding or treating those sources upstream. That's uh, the way to go.
Yeah.
Like, never mind treating all the water we drink. It's insane to do that.
Go after
Let's
the source. Go after the source.
and have them pay.
Yeah.
Who's responsible for those should pay for it, and not the taxpayers who has a right to drink safe and reliable water.
Yeah. Last question I wanted to ask you. Technology is changing so rapidly,
Yeah.
right? And equipment and all this different stuff. So what are your thoughts on that? And I imagine you all are pushing the technology to keep evolving, be more effective, efficient. Just what's that side of things look like?
Well, that's an important question. Water treatment has been there for quite a while,
Hmm.
so there's a lot of conventional approaches and which are reliable and cost effective that we must put in place and continue to use. But destroying PFAS and other contaminants that are coming, we hear a lot about bioplastics,
Hmm.
all the pharmaceuticals in the water as well, and there's a lot of other products like plastic additives, for example, that end up in the water. They will all rely on new technology at lower cost. We will rely on a lower technology, high technology, lower cost to destroy them for sure. So we've heard recently about plasma technology to destroy PFAS. Recently met with a company that does coatings for aerospace materials. But to do those coatings, they need extremely high sources of heat. And they use plasma torches to do those treatment or coatings. And as a side business, they started destroying stable and dangerous contaminants.
Hmm.
That's a very interesting approach, and that's going to be very destructive because the prices of using those technologies, if you have small volume, is impressively low.
Hmm.
We'll be looking at all those technologies from other spheres. We could go to the incinerator and burn them, but the efficiency in doing so is low.
Hmm.
So we're actually displacing the problem. Burn some of it and then let go a too large a proportion into the environment. So
Hmm.
right now it may be acceptable because that's our best doable, achievable approach today. But we really need to do better. So there are wet air oxidation, plasma technology, electro technologies, and others that we seek for the future for sure.
Yeah. Fantastic. Well, I'm really glad to catch up with you. Look forward to continuing to follow Ultra Solutions. Again, you've got decades of experience already working on PFAS, and then you're on the other end, kind of staying up on this cutting edge approaches and technology. So, Martin, thank you very much.
Well, you're welcome. That was my pleasure. Thank you, Travis.